This conference will now be recorded.
Hi, everybody. Welcome. Today, we're going to review the application of using some DIELECTRIC HIPOT test equipment with printed circuit boards. Thank you for joining in. There's my email address if anyone needs it, chat@dielectric.com. All right, so throughout the presentation today, there's a couple points where you're going to see where this slide. So if anyone has questions, that would be the time to unmute and ask away. Like Susie said, you can also ask a question in the chat, and we do have some people monitoring that. That will either be able to answer your question immediately, or we will get back to you, depending on how much research it takes. So here's kind of an overview of the company. This is the DIELECTRIC, the HIPOT and safety division. So we've existed for 30 years now. Founded in 1990 here in San Diego, California. Currently serving over 30 countries with representatives in all 30 of those. Our key product lines are HIPOT testers, cable test systems, which is very similar, I should say, to our printed circuit board test systems. And then power analysis, the 4700 high volt meter, electronic loads, and as of last year, digitizers. We serve a broad industry, so semiconductors, LED, DC power supplies, things like that. We're in a lot of medical manufacturing facilities and mil-aero as well. Here you can see some of our customers, also very broad, everyone from compliance labs to the green and sustainable energy space, as well as your standard American manufacturers. So breaking down those product lines a little bit further, with some visual representations here, you can see a couple families of HIPOT testers. It's the 95X family, the V7X. There's some overlap between them, but we'll talk a little bit later about the differences. There are 3 different power analyzers, the PA 900, 910, and 920, that have different accuracy levels, input ranges, things like that. There's the DL DC loads, about 6 different flavors of that, and then the high volt meter, which is designed to measure up to 10 kV directly, and then up to 140 kV with the probes pictured. All right, so what is HIPOT testing? It is short for high potential. That's where we get the contraction HIPOT. It's a dielectric withstand test. Basically what we're doing is we're confirming that there's enough insulation between line and neutral for your mains power and chassis or earth. With that test, we can verify that the insulation is sufficient if there is a voltage overshoot or something like that from the grid. So there's a variety of different applications. They all break down to basically doing the same thing, and we're measuring that isolation barrier in between 2 conductors. That could be 2 conductors in an automotive wiring harness, a printed circuit board, a cable, even a photovoltaic cell. So if you look at that schematic, they're all going to look very similar, with nodes that should be connected and nodes that should be isolated. And that's really what we're going to try to either do a no-go test on or quantify the value of some insulation there. So when it comes to printed circuit boards, there's a handful of standards. There's actually a couple more, with, I believe, 796 being far and above the most popular. But there are the standards that you're going to test to. So there's obviously a lot of things when you purchase this standard, and we're going to be a small section, just a few pages in that are going to be specific to the safety. And when it comes to PCB, there's really a lot of overlap with quality, not just safety. It's important that this thing is manufactured properly. All your layers are registered and aligned properly and things like that. So the HIPOT test really is going to be, other than a visual examination, it's going to be your best quality test. All right, so it's important when you're doing these test steps and traceability. All the electric products are going to ship with a NIST traceable cal cert. And if you need data, we can also apply an accredited 17025 calibration to your products. All right, so we talked about it a little bit. This here is kind of a diagram showing that we're going to put high voltage on line and neutral, and then we're going to test that isolation barrier to ground for the chassis. Typically, it's 2 times the mains voltage plus 1,000. Test times can be anywhere from sub 1 second to 60 seconds or more. We have customers that are doing a lot of long-term testing with the switch in the 950 to really see what's going to happen to their products in 5-6 months, even a year. So an IR test is really the same thing electrically. The difference is that we're going to quantify the value of the insulation in ohms, where on the HIPOT test, we're typically going to display the current in amps. At the end of the day, they're very similar. But we're going to be, in IR, usually looking for somewhere above 100 megohms. In the gigs is pretty common. And these are usually done in a little bit lower voltages, usually 500 or 1,000 volts, sometimes as low as 50. All right, and then the third test that you're going to see done in these printed circuit boards is going to be a continuity test, or in some cases, a ground bond test. Especially with some of the heavier copper boards, we want to make sure that we can flow sufficient current without having any heating up, which would cause the resistance to increase and potentially fail the test. So we're able to do ground bond tests with up to 40 amps of source current, verify that the proper amount of copper is on the board and the connections are robust. All right, so there's a couple different ways you can fail. And there's limits surrounding all of these that can be set up in the tester itself. So the most common is going to be failing leakage. You're going to set a limit that's either going to be, typically you're going to set a low and a high. So let's say you were testing in a range from 1 milliamp to 5 milliamps. If you didn't connect that product at all, you could fail minimum because you would have 0 leakage. And if it was bad, you could exceed that and have 6 or more milliamps of leakage, and then you fail. There's also a breakdown or a flashover event. Let's say it's going to either creep across or travel via air and break down to the plane next to it or an adjacent trace. That would typically trigger a breakdown failure. And then there's the arc. So arc is interesting because you're going to have a momentary breakdown or flashover, but then it's going to extinguish itself, and then the current will drop back down. Sometimes it's audible, sometimes it's not. That's going to be a much trickier thing to detect. We can set limits around the amplitude and the duration of those arcs, and as of last month, we can actually count them. We released a new firmware tweak for one of our customers that allows us to count the number of arcs that occur during a test. And then obviously high resistance, if you're doing any of those continuity or ground bond tests, you can just fail because the resistance is simply exceeds your limits. There's no questions, we will continue. All right, so the main instrument that's really the brains behind the test and measurement side with these printed circuit board test systems is going to be the 95X HIPOT tester. This is the source and measurement unit. It's got a wide range of outputs from as low as about 25 volts up to 30 kV. Really the sweet spot for this thing is the 5 to 10 kV high end kind of voltage requirements. We're looking at 100 picoamps of resolution on the current side, so we're able to measure very, very low levels of current, which translates to very high levels of insulation resistance in your products. Here you can see there's a few different flavors of the 950. The biggest difference being higher output voltages at the expense of current typically. So you can have the standard unit is going to be 6 kV AC and DC. You can take that up to 15 kV DC, 10 kV AC, and then we do external transformers in excess of that up to 30 kV AC. All right, so what really brings us together and makes the system work for printed circuit boards is the 964i switch. So what this does is it allows, through our software or directly from the 950, to control a customized suite of single pole, single throw relays. This gives us almost no limit. We can string a dozen of these together, which would give you hundreds of high voltage output points, hundreds of return points, as well as continuity source points. We could do 4-wire Kelvin measurements if you want, all kinds of different things. This is where I encourage you to reach out to us directly, and we can talk about your application and work up a diagram that would work for your printed circuit board. Once we determine that, these units are going to get stacked together, sometimes in a rack, sometimes it's just a couple of units, with Quick Test Enterprise typically being the front end, and then your DUT might end up in a safety enclosure like that, and we're going to run some tests and create some data. So this is kind of where we talked about what we're looking to do here. Up to 15 kV is really the limit on that 964. We can go to 70 amps. 250 test points is pretty common, although we can go higher than that. Test speeds can be 100 milliseconds or even faster in some situations. So there's a variety of different relays that can go in that 964 depending on your applications. We have some that are best for higher throughput, lower voltages, around 2000 volts or less, and then we have relays that go up to 15 kV. So this is really where we need to pick the right relay for the job. They also have different current carrying capabilities, so it's important to match up the relay with your application. So this is kind of what we like to start with. We're going to look at your parts diagram, or diagram of your part, and then we're going to configure a 964. And here we're depicting every single relay individually in each chassis, matching it up with your contact points and your test points, and making sure that everything's going to work. This really is the key to your 964. You'd use this as your programming guide. And it's really reference material. This also becomes the build documentation for us so that we know exactly what relays are going to go to which terminals, and make sure everything's right. And then when you go to order a second one, we can perfectly duplicate that system. So one of the challenging things with printed circuit boards is the fixturing. And we work with Cortec on these. We don't build these in-house. They can basically use pogo pins or all kinds of different probes to make contact at the appropriate points, which you'd see here on the diagram. That is ultimately going to link the terminal number with your test point, which would be a pin on the fixture, and we go from there. So there's a variety of different ways we can do it. Here we're testing multiple printed circuit boards at one time just to increase throughput. Another example of that fixture. So if you didn't want to use a fixture, you're limited to things like this test pistol or a pencil probe like this. And it really is going to be, and this might be the way you're doing it now, one test at a time. It's going to be slow. You don't know if you missed any points. And this is why we recommend, making the capital investment into a proper test system. All right, so safety is huge here also, and this is why we recommend the enclosures. The HIPOT testers themselves are designed to shut down quickly if there's any unaccounted for current. But with that said, don't touch the printed circuit board or the DUT. Use the interlock on the HIPOT tester. Verify all your connections, and don't touch anything until that high voltage light is out on the HIPOT tester. If there's any more questions, ask them now. Otherwise, we will continue. All right, so what really ties this whole thing together is the software. The HIPOT testers themselves really could be black boxes, and the 964 and your main interface is going to typically be Quick Test Enterprise, although we do have a lot of customers that have written their own software to work with these 964 and 95X systems. So the benefits here is it's going to allow you to quickly develop a test. It's a graphical interface. You can check boxes to close relays, save all of those different test sequences, and then everything can be exported. So you have the ability to serialize each thing, store data, graphically look at what's going on during your test, and then apply those pass-fail limits during the test. So this is kind of an example here of where you would go through and set up your relay switches. So this is your bank numbers right here, 0 through 7, and these are your relay numbers, 1 through 64. So basically during a switch step, which is the switch matrix step, you're going to go through and you're going to select which relays you want on or off during that. So in this case, we only have one relay turned on in this step. After you pick the relays that are going to go on, you're going to select new, you're going to go to your next test step, and then you're going to probably do a DCW test. You're going to pick your voltage and limits and things like that, and then you're going to follow it up with another switch step where you would typically, uncheck relay 1 and maybe check relay 2 or a corresponding relay over here on the low voltage side. And here you can see exactly what the sequence is once you have it written. So you can see it's going to be a switch step followed by a 3000 volt DC HIPOT test followed by another switch step. And that could continue. Sometimes it's 16 steps in this case, but it could go much longer than that. All right, so this is where at the conclusion of the test, you're able to find some information. You can see when the test was ran, what tester was ran on, the serial number of that, DUT model and serial number, who ran it, whether it passed or failed, and all of this information stored. So later you can go back and find, you can look at your throughput by user, by tester. You can find out that certain DUTs have higher or lower pass rates than other DUTs, and really analyze all of this for quality and performance. So that's kind of it. Didn't want to take up too much of your time, but if anyone has any questions, I encourage you to reach out to me personally, chat at Vitrek or sales at Vitrek, and we can help answer your question and figure out if investing in a printed circuit board testing system is right for you. Please let us know.
Hey Chad, this is Devaraja. So can you send me some procedure or steps to use 959i to do a ground bond test?
Yeah, we can do that. So you said the 964i for ground bond.
No, it is 959i.
Oh, the 959. I can. Are you going to be using it directly or with a switch?
Directly.
Directly. Okay.
Thanks, Chad.
Thank you very much.
Okay, thank you everyone for attending. And as I said, I will send everyone a follow-up email that includes a copy of the presentation and a link to the recording. And you're welcome to visit the website, vitrek.com, and we have a seminar series coming up over the next few weeks. So I'll also make sure you're included that's included in your email. So if you need anything else, feel free to reach out to us, and thank you for your time.
Thanks, guys. Good
Thanks,
luck.
Susie. Thanks, Chad. Bye.
Thanks. Bye.